Thanks, Kim, for inviting me. I am certainly not an expert in biochar, but I have had, how do I say it, differing experiences and different drivers to get involved in biochar, and I think that's probably why Kim wanted me to talk. It's not so much that I'm an expert or anything like that, it's that I've been involved in it and trying to utilise it where possible. You're doing the clicking? Good. Give you a bit of my background. I've been involved in agriculture, farm management for 45 years throughout Australia, not just in the Riverina, but throughout Australia, but mainly in the last 25, 30 years around Jerilderie, like David over here, but working for Rice Research Australia for a lot of that. So got involved in rice production systems, understanding throughout the world, I guess, how they grew rice, and believe it or not, biochar is used quite widely around, especially Asia, in rice production systems, and they don't bring in, I suppose, produced fertilisers that much. They try and do whatever they can to utilise what they've got around them, and that's why biochar gets used in their rice system. More recently, I've been lucky enough to project manage a rice mill at Jerilderie. It's got built last year, and for nice rice, and that's been I suppose, a eye-opener in that we've all of a sudden got these waste streams or byproducts from the rice milling system that you've got to utilise what you've got, and at the moment they're going to animal bedding and so on, and that's probably not the best use of it, and we know that you can do a pretty good job with rice hulls in biochar, but there's also the other side in the farming system, the rice farming system, with the waste straw that typically gets burnt these days, and trying to utilise that rice straw in biochar is the other side of it. And I have been involved in some trials along the way, and I'll run you through a couple of them, that we used the rice straw biochar in trials, and with reasonable success, I suppose. It's probably the longer term effect that we don't know the answer to yet, so we might go through that. And I guess had my own little baby farm at Baruga for a fair while, and 30 odd years, and been slowly trying to convert to a regenerative practices. I don't mind saying that. It's been a long journey. I don't think the word regenerative was around 35 years ago, but it is these days. So just trying to do things a bit smarter and a bit better with the soils. That's all it is. And certainly biochar fits into that regime pretty well. So I've got renewed interest since, I guess, doing this rice mill, but there's lots out there, and Russell touched on many of them. There's so many sources that you can form biochar, there's so many ways you can do it, and there's a lot better ways than bad ways, so just understanding all that as well. Thanks, Kim. I'm not going to go through all this, but this is sort of data that's been created from the rice industry, you know, the uses of rice straw. There's so many different ways and means of utilising the rice straw, and, you know, trying to use it in its best way. It costs a lot of money, believe it or not, to bale rice straw or cut and bale rice straw, and to get it into a form that you can actually make biochar in. So that's a challenge in itself. And does it work in the circular economy system, or does it work in the carbon cycle system, you know, if you're burning diesel to make carbon? So you've got to look at all of those equations and do a business case to make that. I probably haven't got the answer to today to tell you that one, but at the moment, from the little bit of work we did do in the research, it was about a zero balance on both carbon and in cost. So just to give you an idea, it cost a fair bit of money to make it, but you receive the money from making it, so it's not too bad. If you were to use the carbon formed in the biochar back on your own soil from removing the straw, you're slightly in front, but if you did it every year, you'd be in front, no problems. But if you just did it once in every 5 years, like growing a crop of rice, then you'd be about even. So just to give you an indicator. Yep, you can move on. That was the trial we set up. You probably can't read that from there, but we basically had 4 reps. We had the stubble removed. We had the stubble incorporated into the soil. So this is rice stubble we're talking about. And then the stubble removed, and then biochar added. And then there was the stubble burnt, which was a traditional method probably. So there's a few different methods we looked at. And if you go to the next slide, yeah, I think so. Yeah, so we looked, sorry, I didn't mention, but we also looked at drill sowing versus aerial seeding in this trial. So it's, sorry, I'm not here to give you a rice lecture. Sounds like it. But we did find that just removing, I guess, going to a drill sowing system, we got about 50% less methane emissions than going from the traditional aerial sowing method. And later studies have shown this to be around 4 times less. So that's a good thing. And if you're going to do rice straw, then drill sowing's a hell of a lot easier to utilise or to cut and bale than the aerial sowing system. And another key outcome of the project was we talked about pyrolyzing stubble, which is basically biochar, and reapplying it to soils. I said it doesn't necessarily increase methane emissions, which was thought to be the way. So it stayed pretty neutral, and it did increase nitrous oxide emissions slightly. So they're the sort of things we've got to consider, but methane's the nasty one when it comes to greenhouse gas. So, and also it resulted in significant increases to soil carbon in that area. We did do some monitoring. I'm not going to go into the details of every soil test, but it did increase it over time, and that was, I guess I'll put another slide in at the end to give you a figure on that. It's not a great deal, but it just does improve it over time, and it's probably the bio effect, so the bugs and everything else that work with the carbon that actually give you the benefit. The challenges with handling waste in a rice farming system, so I mentioned rice straw and rice hulls. We generate up to 10 tonne of rice straw in a crop. It's a fairly large amount. It's usually burnt, which isn't ideal by any means. Every tonne of paddy rice, so I'm talking about the grain here, it produces 200 kilo of hulls or husks, and the current use is livestock bedding. The questions that I ask are, how do we improve the carbon cycle? How can we close the loop on the circular economy? And the cost of producing biochar versus the benefit. They're the sort of things that challenge me every day, I think. These are some of the lab results from the biochar we tested over time, and I'm not going to say these are what happens every time because different pyrolysis systems generate different outcomes. So this is just a couple of lab results that were done. But you can see total carbon 44.8 is pretty high, and probably the pH is the other thing, it's really high, and that can be moderated, buffered without too much problems, but I don't think many people in this area have got pH problems. They're usually acidic if they've got them, so yeah. And there was probably the other thing that in rice straw is the silica content. It's 58%. It's really high, and you've got to manage when you're burning or pyrolyzing rice straw, you've got to manage that silicon. You can't basically allow it to go out in the air. You've got to try and contain it within the burning process, and that can be done, so that's a good thing. Yeah. Sorry for so many slides with writing. I'll get through some pictures soon, so that's a good thing. From rice hulls to biochar, what we're really after, I guess, is we've got the benefits from carbon capture, the residue generation. So during this processing, the rice hulls are separated. Normally we might be burned or left to decompose. We can, and I'll get to it, but what we can do is during the burning process, you can actually use that burning energy or to create energy as well. So it's a bit harder and a bit more costly process, but if you can utilise the energy, say in a rice mill, that's a good outcome. But I'm still challenged by which system to use overall to make biochar, and we've done a few business cases, including Russell. So what the best outcome is, I'd love somebody to tell me, but I don't know it yet. And what we'd like to do, this nice rice, we've got about 15,000 tonnes of paddy rice to go through a year. It's not a lot, but it generates a fair few rice hulls, and if you looked in the paddock, it generates a lot of rice straw. How do you utilise that best so you can sell it back to you or work it back with your farmers that are already delivering to you? So it's a challenge. Yeah, thank you. I won't go through each one of these individually because there's such a lot in here, but I tried to, if somebody wanted to read this on a document, it's actually a good way of breaking it down. But the long-term carbon storage is probably the most important part. How that carbon works with the soil is the next part, and this microbial life, supporting microbial life is probably the most important one. And we've heard both Russell and Melissa mention already, it's not just about biochar, it's how you add it or incorporate it or use it. So it's not just a single fix, it's a combination effect, I guess. And we're trying to reduce emissions. That's not rocket science, but if you are in a business like Nice Rice, for instance, if you want to sell your rice at a slight premium, it's coming now pretty well, not just in Australia, but around the world. We've actually got to lower our carbon effect. We've got to show that we're preferably net zero or better. And the other side of it is the circular economy part. If you can show that you're utilising things in every component well, it actually sells rice. And people starting to pay a premium. I won't say they will pay a premium. A lot of people still go to the cheapest rice on the market. But hopefully in the future there is some recognition of that. I won't slip past that one, sorry. This is easy to understand. So this is the circular economy thing I went into. So basically our harvest, rice processing, the hulls, the pyrolysis process, and then soil enrichment. And can we improve crop yields? Yes, we can. It's probably the simple answer, but how do you measure that is the difficult answer. And what we've seen is in our trials that we did at Rice Research Australia, there wasn't significant yield increase, but I went back there only a few years ago, which was about 5 years after the trial, and you can still see the strips of where the biochar was applied. So that's what else is happening there, I'm not quite sure, and what biology's in the soil there now compared to what it was originally, I'm not sure. But these are the sort of things I think we do need long-term trials to answer the questions. Yeah. And then again, just looking at the carbon cycle side of it, it's the same circle, but where do we get the benefits? I think it's probably all of these: improved soil health, the sequestering of carbon, and then the reducing emissions. So we're really not going to probably see the immediate effect straight away, but we're going to see it over the next 10 years. And probably if you keep applying, you're going to see it for 100 years. And I don't know about the farmers in this room, if there are many, but the farmers would like to, reduce their chemical inputs at the moment, I know, because they don't want to be putting diesel out. They don't want to be probably buying urea because it's pretty costly. So there's a lot of things like that that we've got to consider, and that's where I want to head anyway. Yeah, Kim. And just this is a summary of one of the estimates that we looked at, and this is something from a biochar plant, and Russell knows this better than I do, but the total rice husk input is just estimating it somewhere around 2,500 tonnes, putting through a throughput of about 380 kilos per hour, and assuming a 45% yield on dry matter, which is probably reasonable out of biochar from what we've seen, we get about 150 kilos, which doesn't sound much per hour, and that's why you need an efficient system to do it. You don't want people standing around, you want probably one person standing around to run something like that. And then scaling that system is the difficult part too. So the total biochar-based fertiliser that can be pre-produced is around 4,000 tonnes, so we're not talking about applying it singular. We're actually mixing it in to make something that's useful for the soil with an additive. And I won't go into the BTUs from the heat, but it's talking about the actual power consumption that could be generated from the hulls while doing the biochar process. So that tries to counteract itself, basically. And there's lots of different systems. I know we've looked at a few, and not just in Australia. So there's some systems that are being in use in Cambodia at the moment, for instance. There's 3 of them, 3 plants. This one, for instance, in China. They're all over the world. Finding a system that is efficient and cost effective is the challenge. And it is a challenge when you haven't got one just around on your doorstep. We're about to have one on our doorstep by the sound of it, but it's not easy to work out which system to put in at the moment. Yep. These are some of the other ones. You can get these mobile skid-mounted systems. They are pretty simple to obviously utilise, but then you get to the bigger ones that are the continuous biomass production systems, which sounds like the most efficient, but obviously the most costly. Yeah. And then this is almost my final slide, I think, but the business case that we're trying to answer at the moment, rice hulls alone, we've had, for doing biochar, we've had quotes from 50,000 to 1.2 million. If we look at rice straw and hulls, we've had quotes to 13.5 million. And then, the return on investment at around 8 years. And that's not considering any carbon credits or anything associated with that. So, from the current research, well-made biochar applied at 1 tonne per hectare will increase soil organic carbon by about 0.5% if you're doing soil measurements alone. But we know it's not just alone, so that doesn't mean a lot. The added benefits of water holding capacity, the increase to cation exchange, and the biological stimulation have not been quantified from my knowledge, and I'll be honest, I've chased it pretty hard around the world in mainly rice-based systems, but it's hard to get a quantified outcome, but you can talk antidotal, and there's plenty of evidence there. So that's about me, I think, isn't it? Thank you very much. But any questions? Yeah.
Russ, all the other speakers, is this, can this have a similar effect to using gypsum question as well with soil structure. Are we having did you see soil structure improvement?
Yeah, I guess from the bit I've done, and it is anecdotal, I haven't done any physical measurements or chemical measurements in the last 5 years. But that soil is, I guess, what we're seeing is there's more hypha, there's more fungal activity in that soil, but I suspect it's a flow-on effect, not necessarily from the biochar alone. It's biochar, we have mixed some foliar ferts and we've done some soil amendments as well. So it's pretty hard to quantify which part of it was doing it all. So don't know if you want to comment, Russell.
Well, I'll just say there is a lot of published papers out there actually on that using biochar as an alternative source to gypsum, but also an alternative source to lime. I know there is a concern about its use on alkaline soils because it is alkaline, but you can treat it. It isn't too, it depends on the feedstock and how it's produced as to what its pH is. But biggest growing trend of biochar use is actually the synthetic fertiliser, and that's really timely actually because urea is costing $1,500 a tonne, and you can just apply small amounts, 20% biochar with synthetic fertiliser, and there's published papers that show you can half your fertiliser rates with 20% addition of biochar. So there's a lot of that summarising this, but I'll talk about some of that. But yes, there's if you know a biochar problem, I challenge you to Google it. There's probably a paper on it.
There sure is. There's a lot of
Just saying, further to that, Russ, to say it can be used rather than using lime because we are probably acidic more, so our soils tending towards more acid type soils.
I don't think so. I think it'll only help. As soon as you start producing carbon, normally the whole cycle that's happening in your soil will help to improve your pH. So,
Will it build carbon?
Absolutely, because it is carbon. I mean, depending on how it's made, biochar can be up to 95% carbon. It is carbon.
But if you're adding the carbon, will it build carbon?
Yes, it will. So it will build carbon 2 to 3 times the amount of carbon in the biochar, and there's this kind of priming effect. So it will increase over time. If you keep applying small amounts, it'll keep increasing and increasing and increasing. So, you know, that's first bit will increase 2 to 3 times. You put a bit more and it'll increase 4 to 6 times. And there's actually no recorded kind of limit on how much you can build the carbon by. And I think that's the thing in cereal cropping especially, and rice, where you're taking biomass and carbon off all the time. And you don't have year-round living plants that photosynthesize and fix carbon. There's no other way to do it but add it. And so I guess that's the ethos of biochar, is you're recycling your carbon back to the soil and then you're improving the soil health and carbon, which is what both of the speakers have spoken about.
Yeah, I think that's the whole way, like it has an impact and flow-on effects because you're adding like a small, depending on your application rate, amount of carbon, and then that's having a positive impact on your soil physical properties and chemical properties and biological properties. So as you sort of build up your organic soil carbon levels in the soil, just sort of that sort of increases soil structure, increases pH in your buffering capacity, nutrient holding capacity, water holding capacity. So you're not getting measured increases necessarily, but we know that it can have those long-term sort of impacts and flow-on effects from having it. So it's not biochar specifically that does that, but it provides the sort of catalyst to sort of have and support those processes in the soil.
Beth?
Might not be a question for you, Russell, but presumably the chemical properties of the product are going to vary slightly depending on what it's being made from. Like biochar from rice hulls will be slightly different to biochar from wood chips.
Most definitely.
Yep.
So is there any implications there in terms of use and application if someone thinks they're just getting
I think
biochar?
I'll give you my answer, which is probably different, but I think most people who applied biochar are after a carbon source. That'd be my first point. And then how you utilise it for the best outcome of what you're trying to grow, because usually you're adding it to the soil for a growth reason. How you utilise that and mix it to get your outcome, I think you almost have to learn your own recipe. So yes, they'll have different analysis through a soil test, through a test after being pyrolyzed, but how you utilise that to your benefit is the difficult one. Like I said, silica was really high in the rice one. It might not be in the wood one, it won't be in the wood one. So that silica has great benefits in, plant health, for instance. So how you use that one, and it might be good for vegetable growing versus it might not be so good in growing a wheat crop, but all of those sort of things, I guess, that you got to consider. And anyone else want to comment? Yeah.